Welcome. Physics is often called the foundational science. Foundational in the sense that all the other sciences find their roots in physics. Chemistry, biology, physical sciences, and all the engineering disciplines. My sister is also a physics teacher, likes to refer to physics as math with a purpose. I like to think of physics as putting equations to what we observe happening around us. And as an example, gravity. We're all familiar with gravity. We know that if we take an object and we let go, it's going to fall. We call that gravity. But what's really interesting about the way God has created this universe is that if I know the mass of this thing and I know the mass of the Earth, there's actually one equation that will tell me what is the force of gravity between these two objects. And that equation is simply the force of gravity is equal to big G, called the universal gravitational constant, which is the same number everywhere in the universe, times the mass of the first object times the mass of the second object, all divided by r squared, where r is the distance between this object and the other object. Pretty straightforward. Well, gravity isn't the only fundamental force. There's actually 4 fundamental forces. I know. Some of you are thinking, well, there's research scientists out there, doing work to break down the boundaries between each of the 4 fundamental forces, similar to what Maxwell did when he discovered that electricity and magnetism weren't 2 different things, but were actually the same thing. But for the purposes of teaching for this class, and I think without introducing any error, we can cover each of the 4 forces, 4 fundamental forces separately. So what are those 4 fundamental forces? Well, there is and we'll rank them from strongest to weakest. The strongest being the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity, the one we've already looked at. The strong nuclear force is the force that's in the atom, in the nucleus of the atom, that holds the protons and the neutrons together. Okay? The weak nuclear force is also in the nucleus of the atom and is involved in the processes of decay and also with fusion. The third fundamental force is electromagnetism. In electromagnetism, we see that all the time, every day. For example, we turn on a light switch, light comes out, that's electromagnetism. We use a microwave oven to cook a meal or heat something up, that's electromagnetism. We use our cell phone to talk or text, that's using electromagnetism. So, and then finally, which we've already talked about, gravity. All right. Now, gave you a demonstration on gravity, but I want to give you a demonstration on something in electromagnetism. And since electromagnetism involves magnetism, I thought I'd start with a magnet. But I want to convince you first that this is a magnet. All right. It says N and S for north and south, which hopefully by now you're aware that magnets have 2 poles, a north and a south. But we also know that magnets tend to stick to things that are made out of iron. And you can see that it sticks to this whiteboard. And it doesn't matter whether I use the blue end or the red end, it sticks. Okay? So just in case you're not convinced that that's a magnet, I do have, maybe you'll remember back in an earlier science course you had a magnet and a piece of paper and some iron filings on it. And you put the magnet on one side of the paper and the iron filings on the other, and then those iron filings all lined up, to show us visually the magnetic field created by the magnet. And so what I've got here is kind of a 3D example of that, where I've got iron filings inside this plexiglass case, and I've got the magnet in the middle, and the iron filings have now aligned with the magnetic field, and it looks like a very, very fuzzy hairdo here. Okay? So at this point, hopefully I've convinced you that this is a magnet, and we can move on with our demonstration of an electromagnetic event. So the other part of this demo is that I've got a metal pipe. It's a hollow metal tube. Okay? It's made out of aluminum. As many of you know, magnets do not stick to aluminum, and so we've got the magnet here. I've got it held to it, but if I let go, it's going to drop. So it does not, stick to the pipe. But it is aluminum, and it's metal, and it's a hollow tube. One other thing I do want to show you is that if I put this magnet inside, you'll see that there's actually quite a bit of room inside there. So it's got lots of room in there. It's not rubbing against the edges. But before we do, the actual observation here, I do want to just check and make sure that gravity's working. Okay, good. Gravity's still working. So let's check this out. Let's see what happens when we drop this magnet down through this metal tube. Okay? Let's try it. And we'll start with the red side. We'll go with the red side first. See what happens. Okay, let's check and make sure gravity is still working. Okay, gravity is still working. All right. We did the red side. Let's do the blue side. See if it makes any difference. Okay. That's interesting. Let's just check. No, gravity is still working. So what is going on here? Well, this is one of the topics we're going to cover in our physics class. And lesson 15 specifically is on electromagnetism. And by the time we get through lesson 15, you will actually be in a position to tell me exactly what's going on with this magnet, this metal tube, and gravity.